The first thing I'll say is in this question was it said if a triangle is an acute triangle, in other words, all the angles are less than 90 degrees. In other words, not this example here or not this example. In that case, you get a squared plus b squared is greater than c squared. But let's look at a right angle triangle. When it is right angled, we know that a squared plus b squared is actually equal to c squared. That's Pythagoras. Now look at this way. Let's a and b are the same length. We won't change those. We just change the angle to be obtuse. And we increase c by a little bit. So if c is a little bit in order to kind of make this an obtuse angle, then we're going to get a squared plus b squared is going to be less than c squared. Because a squared and b squared haven't changed, but c's got a bit longer. So if it's an obtuse angle, you're going to get this situation. Now let's make it c is a bit shorter. A and b are still the same, they haven't changed, but we just decrease c a little bit, and we make this an acute triangle. So c gets a bit shorter. Well, obviously then a squared plus b squared is going to be greater than c squared. Okay. Now let's look at the question itself. It's question 17, page 179. And we're given a triangle with the lengths 2x, 3x plus 4 and 30 is the longest side. So, and then it tells us if the triangle is acute, blah, 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 it says that a squared plus b squared is greater than 30 squared. So we plug in our values, 4x squared and so on, and we get a quadratic equation like this. And then we solve it using the quadratic formula. And we're going to get x is greater than 7.37. I think we're also going to get a negative number, but obviously the side of a triangle can't be negative, so it has to be this value here, x greater than 7.37. So that's one of the constraints, and it's saying that in order for us to have an acute triangle, x must be greater than 7.37 units. X could be a million, in which case it wouldn't even be a triangle. So that's just one of the constraints. Let's have a look at all the other constraints. And the simplest way to do this without any thinking really is just use this particular rule, that any two sides must be greater than the third side. And just do them all like this all the time. You don't have to work at minimum or maximum. You can just work out this particular rule and it'll give you everything you need. So I'm going to take 2x plus 3x plus 4 is greater than 30. I solve that. I get x has to be greater than 5.2. I take another two sides. 2x plus 30 must be greater than that. That means x must be less than 26. That's another constraint. And then the third one is that 30 plus 3x plus 4, the two bigger sides, have to be greater than the third one, and that means x must be greater than minus 34. So, okay, there are three constraints. If I go over here, I can see that x must be greater than 5.2, it's all up there forever, but it must be less than 26, so it must be kind of down here as well, less than 26. Goes on forever, by the way. So obviously at this stage we're talking about, this kind of scope in there. And then the next thing we have that x must be greater than minus 34. So, right. So now we have that we're looking at this area in here. But also, in addition, 30 is not just one of the sides. 30 is the longest side. So we have to have these two constraints as well. 30 is the longest side. So 2x must be less than 30. So x must be less than 15. And then the last one is 3x plus 4 must be less than 30. So x must be less than 8 2/3. So if I remove this junk here, all this orange stuff that I got a moment ago, okay, we can see now that our main constraints are that x must be greater than 7.37 in order to give us an acute triangle. It must be less than 26, but it also must be less than 8.23. Okay, so it must be in this particular gap here. All the other constraints are satisfied. X must be greater than 5.2. Yeah, well, that's satisfied in here. X must be less than 26. That's satisfied in here. X must be greater than minus 34. That's satisfied in here too. X must be less than 15. That's satisfied in here. And X must be less than 8.23. So there we go. So what will make a triangle, and will make it a acute triangle, is a value for X which is between 7.37 and 8 2/3. To have fun with this, or to prove it that it's correct, if you use the cosine rule, okay, and I plugged in 7.3, which is just a little bit below 7.37, and I get an angle of 91 degrees. And then I put in 7.4, which is just slightly above 7.3, and I got 89.6. So it's an acute triangle. I didn't try 8.23, 8 2/3 should I say, but if I plugged that in, that would work as well. Just for fun, the cosine rule is we've got 30, we've got 2x, and we have 3x plus 4. put any value you like in. This is the biggest angle, isn't it? Because it's opposite to 30. So the cosine rule is going to be, we'll say 30 squared is equal to 2x to be squared. Put in your value for x. Okay. 30 squared is plus 3x plus 4. Whatever that works out as being, you're going to get some 3x plus 4. I'm putting in the x's here, but you'll be putting in values for x's. So it's equal to minus 2 times whatever the value is, cosine A. Okay, so you're going to get these numbers along here. That'll be a numerical solution, and that'll be numerical. So you're going to get cosine A is equal to 30 squared minus the whole gang of numbers, and it's then going to be divided by 2 times those brackets. I hope this is making some sense. And then you're going to get A is equal to cosine minus 1 of all that stuff there as well. Okay, so if you're a bit confused with that, go back to have a look at the cosine rule, and you can check out your different solutions there. Very last thing I want to say is back on this question. If it happened to mention that x needed to be a natural number, okay, well then there's only one solution for that. X would have to be equal to 8 centimeters or 8 units, wouldn't it? Because it has to be greater than 7.37 and less than 8 2/3. So if it had to be a natural number, 8 would be the only solution that would work in that case.